In case you weren't able to be in class today when we went over 332 notes, this will help with 333 if you'd like to try them. So here's the square root of 36. We're going to first of all rationalize. And the second column is decimal approximation. We'll do that afterwards. The square root of 36 is 6 because 6 times 6 is 36. That's it. It's a perfect square, like the square root of 25 or the square root of 4 or the square root of 9 or the square root of 100. The square root of 50. Well, what perfect square goes into 50 is 25. Since 25 times 2 is equal to the square root of 50, we take the square root of 25, which is 5, and then we have the 2 after it. So the 2 is underneath the radical, and the 5 comes on the outside because it's the square root of 25. We're looking for perfect squares. Another way of looking at these things, you could instead take 50 and break it down and say 5 times 10 and 5 times 2. And say, oh, since I have the square root of 5 times the square root of 5, that's a 5 on the outside with the 2 on the inside because it's left over. You could do it like that too, if that's a preferable way for you to do it. The next one, I'm going to look for perfect squares, but you could break down the 40 all you want and so forth. But I know that 4 goes into 40 10 times. So negative 7 times the square root of 4 is the same as negative 7 times 2. So that's the same as negative 14 times 10. So once again, because the list of perfect squares is so small, I'd rather look for perfect squares that go into a number than break it down into whatever it needs to be broken down to. Seems to me like it's easier. Although the exception would be, it's nice to know that the square root of 5 times the square root of 5 is 5. Because look at the next couple problems. I'm going to skip one. The square root of 311 times the square root of 311 is 311. That no need to multiply or anything. When you have a perfect square, that's what we have underneath the radical. The 311 squared, because we have 2 of them, that means you got a perfect square. So square root of 311 times square root of 311 is the square root of 311 squared. It's undoing the square. Next one, I could multiply 7 and 14 together, but I think we can all recognize that 14 is made up of 7 times 2. So the square root of 7 times the square root of 7 is 7 on the outside with the 2 stuck on the inside. There's a pair of 7s just like there's a pair of 311s. Similarly, on number 6, I hope that you recognize that 22 and 33 both have an 11 in there. So I'm going to rewrite the problem. I'm going to say the outside numbers are 3 times 5. That's this thing and this thing. And then the 22 and 33, 22 is the same as 2 times 11 underneath the radical, and 33 is the same as 11 times 3. So I've got the square root of 11 times the square root of 11 underneath the radical. I've got a 3 and a 5 on the outside. So I would do negative 3 times 5 is negative 15. Square root of 11 times square root of 11 is 11. 11 times 15 is negative 165. Then what's left is 2 and 3. 2 and 3 underneath the radical. There you go. Square root of 6. Now, if I had multiplied 22 and 33 together and then break them down again, it seems like a lot of extra work. But I could do that, but I don't know that it would be obvious that I would have 121 as the factor. Wherever. Anyway, so there's the first part. I would say that before we go into the last part there, that if I was trying to find the decimal approximations for some of these numbers, I would go over to a calculator. For instance, I could go to a Google calculator. Here's one, just a Google search, and I'll say the square root of 36. The square root of 36. I'm supposed to have a calculator here. What is the square root of 36? And there'll probably be some calculator. That's not what I want either. That says 36 squared. That's not what the square root. Oh, I didn't say the square root. Oh, how about that? What is the square root of 36? Okay, the square root of 36 is 6. What is the square root of, and then I could probably do something different. Let's see, square root of 40. That was on our list, wasn't it? We had we were asked to find a decimal approximation for the square root of negative 7 times the square root of 40. So there's the square root of 40, and then we say times square root of times the 7, although it was supposed to be negative 7, so it'd be negative 44.27 because it said, oh, find it to 2 decimal places. Or if I wanted to take the square root of 50, which was the second problem, square root of 50 is 7.07 because I asked for 2 decimal places. Even if you wanted to do the square root of 7, the square root of 7 times the square root of 14, it'll give you an approximation, but that's fine. 5.12 because we go to 2 decimal places. So you can use a calculator, any number of calculators, to find this decimal approximation for our numbers. A Google calculator is fine, but if you have a regular calculator, that's even better. All right, the last 4 are going to be on rationalizing. I'm not going to bother with the using the calculator again. But what's going on here is this is the same as the square root of 5 over the square root of 16. The square root of 5 doesn't have any perfect square factors, but the square root of 16 is 4. Now, the thing is that I can't have any square roots in the denominator because that's some kind of silly rule. So the square root of 16 is 4. And this next one, the square root of 1 over the square root of 10. Now, the square root of 10 can't be in the denominator. So the little trick you use for rationalizing was on video number 2. Multiply the top and bottom by the square root of 10. The square root of 10 times the square root of 1 is the square root of 10. But the bottom is the square root of 10 times the square root of 10, which is 10. The next one, I can't simplify the square root of 6, so I'm going to multiply top and bottom by the square root of 6. Because multiplying by something over itself doesn't change its value, it just changes how it looks. Square root of 6 times square root of 6 is 6. 12 times square root of 6 is what goes in the top. Now, 12 and 6 are both on the outside of the radical, so it's just like simplifying a fraction. 12 divided by 6 is 2. Now, I can't do anything with the square root of 6 over the square root of 6 because one's inside the radical, one's outside the radical. But I can certainly do 12 divided by 6. This next one, the 3 and the 21 are both underneath the radical. So actually, I'd like to reduce that before I get started because the smaller the numbers, the easier it is to do. So I'm going to reduce 3 over 21, since they're both under the radical, to 1 over 7, since it's how it would reduce. Then I can multiply top and bottom by the square root of 7. The top becomes 4 square root of 7. The bottom is 5 times 7, because the square root of 7 times the square root of 7 is 7. 5 times 7 is 35. So you'll notice on these 4, we have an answer that has no square root in the